A small dome sitting on a rust-colored plain, its walls printed layer by layer out of Martian dust, glowing faintly under a pink sky. Inside, a handful of people are growing tomatoes in soil that was once considered toxic to life. It sounds like science fiction, but pieces of this picture are already being tested right now, on Earth and in orbit. I'm James Vince, and you're watching Astrum Orgin. Today we're tackling one of the biggest questions in space exploration. Can humans actually settle on Mars, and if so, how? Mars has always pulled at our imagination. Every few months there's fresh news about rockets, rovers, or billionaires racing toward the red planet. But past all the headlines, one real question remains. Are we actually close to building a human settlement there, or is this still science fiction dressed up as a plan? Let's break down the dangers, the technology, and how close we really are, starting with why scientists picked this planet in the first place. Out of every world in our solar system, Mars looks most like a second home. It has ice, a thin atmosphere, a day close to 24 hours long, and strong evidence that water once flowed across its surface. Robotic missions, Curiosity, Perseverance, and China's Zhurong rover have spent years digging through Martian soil for clues about whether life could have existed there in the past. That curiosity has pulled in private companies too. SpaceX, Blue Origin, and groups like the Mars Society have built their identities around getting people to Mars, not just probes. Getting to Mars takes roughly 6 to 9 months one way, and for that entire stretch, astronauts are outside Earth's protective magnetic field, exposed to solar radiation and cosmic rays, particles so energetic they can pass straight through a spacecraft's hull. Long-term exposure raises real risks of cancer and cognitive damage. Engineers are exploring fixes, lining the ship's walls with water tanks, since hydrogen blocks radiation well, building compact magnetic shields around the crew cabin, or using new materials like boron nitride nanotubes. None of these are fully ready yet. Communication is another headache. Depending on where Mars and Earth are in their orbits, a single message can take anywhere from 3 to 22 minutes to arrive one way. A real-time phone call is basically impossible, so colonists will need to solve emergencies mostly on their own. There's no agreed-upon best spot yet. The polar regions are attractive because of visible ice caps. Some scientists favor craters like Korolev, which holds a large reserve of frozen water. Others point to regions closer to the equator, where sunlight is stronger and solar panels work better, paired with underground ice deposits detected by orbiting satellites. Lava tubes, natural tunnels left behind after molten rock drained out, are another strong candidate. These could act as ready-made shelters, protecting future residents from radiation and wild temperature swings without needing to build much from scratch. Since it's impossible to ship an entire city's worth of material from Earth, most plans rely on using Martian regolith, the loose dust and rock covering the surface, as raw construction material. The idea is to send autonomous 3D printing robots ahead of any astronauts. These machines would mix regolith with ice into a concrete-like paste and print walls layer by layer, then pile more regolith on top as a radiation shield, since Mars has no magnetic field to block it naturally. Once a habitat is sealed, breathable air can be made by splitting water into oxygen and hydrogen through electrolysis, then mixing that oxygen with nitrogen, a similar system already used on the International Space Station. Wheeled rovers work fine on flat ground, but they get stuck easily. NASA's Spirit rover famously died after its wheels sank into soft sand. That's part of why NASA has been testing walking robots like Boston Dynamics' Spot, which can climb stairs, cross rubble, and right itself if it falls. Spot has already mapped cave systems on Earth that mimic Martian terrain, working in teams without any human steering, exactly the kind of independence needed on a planet where messages take minutes to arrive. Experiments simulating Martian soil have actually grown real crops, tomatoes, peas, spinach, and more, though yields were lower than on Earth. The soil does contain harmful chlorine compounds called perchlorates, but these can be rinsed out with water, and ironically, they're also useful, since they release oxygen and pull moisture from the air. Health is a bigger obstacle. Mars has about a third of Earth's gravity, and low-gravity environments are known to weaken bones, muscles, eyesight, and the immune system. Scientists, including teams working with NASA, have even tested basic gene editing tools in orbit, hinting at a future where astronauts might receive genetic tweaks to better resist radiation before long missions. Mars TH.